Namaste guys. After presenting the video on ordered pair and Cartesian product, today I am presenting the video on new topic, relation. This topic, relation, is also directly connected to ordered pair and Cartesian product. So you can visit those videos also. And today let's start the introduction and definition of relation in this video. As in our family, in our society, people are connected to each other by several relations like sister of, brother of, mother of, father of, son of, daughter of, and so many other relations. In mathematics, a number is related to another number. A set is related to another set. And there may be several relations between numbers, between sets. Let's take two non-empty sets A and B, where elements of set A are 1, 2 and elements of set B are 1, 4. And if we make the order pairs of these numbers, where first element from set A and second element will be from set B, we'll get 4 order pairs. You know that all. Cartesian product of A cross B will have 4 order pairs, 1 1, 1 4, 2 1, 2 4, and you will get some specific relations between those numbers. You will get some relation between 1 and 1. Which relation is there? X component and Y component are equal, or X component is equal to Y component, Y component is equal to X component, or you can say Y component is cube of X component, X component is cube root of Y component. There is a single order pair, but you can get various relations there. And in second order pair also, between 1 and 4, you can get several relations. You can say X component is 3 less than Y component, or you can say Y component is 3 more than X component. Those less than, more than, square of, square root of, cube root of are relations in mathematics between numbers. Or in this order pair, you can say Y component is 4 times the X component. 4 times 1 is 4. Similarly, in this, between these two numbers 2 and 1, in this order pair also you will get relations between 2 and 1, and in this order pair also you will get relations between 2 and 4. Either you will say X component is, that means first component is square root of second component, because 2 is square root of 4, no? Or you can say Y component is square of X component, or you can say Y component is twice the X component. There are several relations between the numbers. Let us take some specific relations between these order pairs of A cross B, in which first number Y component is square of X component. Take those order pairs from A cross B in which Y component is square of X component. What are those order pairs in which Y component means second number, second component is square of first component? Let's see, first order pair, Y component is 1, X component is 1, but this Y component is square of X component or not? 1 is square of 1, Yes. So we'll take one of the order pair 1, 1. Next order pair 1, 4. Y component is 4, X component is 1. 4 is not square of 1. The square of 1 is 1 only. No? So we'll not take this. And in third order pair, 1 is not square of 2. We'll not take this also. And in fourth order pair, Y component is 4 and X component is 2. Is X component square is equal to Y component? Is 2 square is equal to 4? Yes. So we'll take this order pair. And set of these order pairs is a relation. Which relation is there? Y component is square of X component. This is relation. Square of is relation. Y component is square of X component. Let us take another example. X component is greater than Y component. See, in these order pairs, we'll take only those order pairs where X component means first number. First number is greater than Y component means second number. In this order pair, 1 is not greater than 1. In this order pair, 1 is not greater than 4. In this order pair, 2 is greater than 1. That means X component is greater than Y component. And among these 4 order pairs, only one order pair satisfies this relation. Greater than. X component is greater than Y component. That is 2, 1. So 2, 1 is only order pair where X component is greater than Y component. So here we'll take only the order pair 2, 1. And set of this order pair is also a relation. The relation is X component is greater than Y component. If you say this first relation R1, then this relation is R2. Let's take one more example. X component is smaller than Y component. We have to take only those order pairs from A cross B where X component is smaller than Y component. Let's see. In this order pair, X component is 1, Y component also 1. 1 is not smaller than 1. They are equal. Will not take this. Will reject this for this relation. And next, yes, X component is 1, Y component is 4. X component is smaller than Y component. So we'll take this. One of the order pair is 1, 4. And in next order pair, X component is 2, Y component is 1. 2 is not less than 1. So we'll reject this also. We'll not take this. And last order pair, X component is 2, Y component is 4. Yes, X component is smaller than Y component. So we'll take that. 2, 4. And set of these two order pairs is also a relation. This relation is between X component and Y component of these two order pairs. That is, X component is smaller than Y component. So if this is first relation R1, this is second relation R2, you can say this R3, third relation. Let's take one more example. X component is equal to Y component. That means take those order pairs from A cross B in which X component is equal to Y component. Here X component and Y component are not equal. Here X component is 2, Y component is 1, not equal. Here x component is 2, y component is 4, not equal. We'll take only this order pair where x component and y component are both equal. We'll take only the order pair 1, 1, where x component and y component are equal. The relation is equal to, and this is relation number 4, fourth relation. Let's take one more example, that is y component is thrice the x component. Let's see in first order pair. Is 1 3 times 1 itself? Never. Reject this. 4 is 3 times 1? 3 times 1 is 3 only, no? 3 times 1 is not 4. That means y component is not 3 times x component. 4 is not 3 times x component. Will not take this. 1 is 3 times 2? Never. Reject this. Is 4 is 3 times 2? No. There is no order pair in which y component is 3 times the x component. So this relation is blank here. This is relation 5. But this is also a relation. For example, if I do not have sister-in-law, then sister-in-law will not be a relation. That is a relation. But in this A cross B, there is not such order pair. So that relation will be empty here, blank, or null relation you can say. So from these examples, I hope you have understood what is relation, but how to define the relation. Also, you can understand from here. Here, these two order pairs are subset of A cross B, Cartesian product. Here, this order pair is also subset of this Cartesian product. Here, this order pair is also subset of A cross B. This order pair is also subset of this Cartesian product, A cross B. And null set is subset of every set. So these all relations are subsets of A cross B. So we can define a relation like this. Let A and B be any two non-empty sets. Set A and set B must be non-empty. Then only we can find Cartesian product. If we have Cartesian product, then only we can find relation. If among A and B any of the set is empty, then we cannot find Cartesian product. If we cannot find Cartesian product, then obviously we cannot find a relation as well. A and B are two non-empty sets. Then any subset of A cross B. See here, these all relations are subsets of A cross B. Any subset of A cross B is said to be a relation from A to B. If A and B be any two non-empty sets, then any subset of A cross B, any subset of A cross B, here you can see, is said to be a relation from set A to set B. Thank you.